Hello there, it's Debbie again. Finding more identities. This time we're going to find the identity for sine or cosine of half of an angle. So if I have an angle and I would take half of that angle, how would I find the sine or cosine of that new angle? Half angle means basically taking the angle divided by 2. And what we can do is we can use other identities. Specifically, we're going to use the double angle identity for cosine. We're going to use the double angle identity that involves only cosine and the double angle identity that involves only sine to help us find our half angle identities. So I'm only going to derive one of them because it's a very similar procedure for the other. So let's derive the half angle identity for cosine. How do I find the cosine of half of an angle? So I'm going to start with, how do I find the cosine of twice an angle? And I'm going to use the double angle identity for cosine that involves only cosine. All right, and I'm going to take that identity and I'm going to solve it for cosine of x. So I want to isolate cosine of x on one side. So I've just flipped the sides to make when I'm done solving, I've got my expression on the left. So first thing I'm going to do is isolate the cosine squared x. So I'm going to add 1 to both sides. And then I'm going to divide by 2 to get rid of that 2 in front of the cosine squared x. Okay, and I want to stop right here because I want to just make a mention about this. If you go to Calc 2, or I should say when you go to Calc 2, you will see this. This is called a power reduction formula. That's used when you're integrating in calculus. And if you're integrating cosine squared or sine squared, then what you do is you rewrite it in an equivalent form where it's only cosine or sine to the first power. So we can see here, this is cosine to the first power. So it's cosine of 2x. All right, so those will come up down the road, which is you'll start out with this same identity. But we want to keep going. We want to remove the square on the cosine. So we're going to apply the square root property to get cosine of x. And we know it's plus or minus. We're going to take the square root of that expression on the right. Okay. Now, this is telling me how I can find the cosine of some angle that we're calling it x. But what I want to do is, and to do that, it's telling me I need to use the cosine of twice that angle. But we need to go backwards, okay? We don't want to deal with twice an angle. We don't want to find this angle x. We want to be able to find half of an angle. So to write this in terms of the cosine of half of an angle and using only the cosine of the full angle, sounds like a mouthful, we're going to do a substitution and we're going to say, okay, let's let 2x be theta. Okay, so I could then rewrite the right-hand side in terms of an angle theta. So we're just saying there's some angle theta that's twice another angle x. So it still represents an angle. So I could rewrite that then as the cosine of theta plus 1 divided by 2. All right, but then I have to replace this x over here on the left. Well, if I said theta is 2x, then that means if I divide both sides by 2, x is half of theta. Okay, so just doing a little algebra there. So on the left-hand side, I can rewrite that as the cosine of theta divided by 2. We're kind of going backwards, really. All right, so we're saying I've got some angle theta that when I take half of it, I've got another angle, right? The cosine of that angle can be found by just taking the cosine of the angle that was halved, so to speak. So it's just using that cosine of the original angle that was taken half of. Okay, so the only thing you'll see different in the identity is they reverse the order here, and I'll write that as 1 plus the cosine of theta. But basically it's the same idea. Okay, so we can use a similar procedure to find the sine of half of an angle. Start with the double angle identity that involves just sine and go through that same procedure. So won't do it twice, it's basically the same. So here are the half angle identities for cosine and sine. So what's the only thing that's different about them? The cosine is 1 plus and the sine is 1 minus. So they're very similar. And the big thing is be careful out here. You're going to have to choose positive or negative. Is that value positive or negative depending upon the quadrant in which the original angle that you're finding the cosine or sine of lies. So for whatever this angle is, okay, it's half of another angle, but what is it equal to? So what quadrant is theta over 2? What quadrant is it in? And then you determine your positive or negative. So let's just verify this, the half angle identity for sine, since we didn't derive it. And I'm going to choose theta as 90, so I'm choosing something we know the exact value of. And if I want to find the sine of 90 divided by 2, well, I know that that's the same thing as 90 divided by 2 is 45, correct? And I know the sine of 45 is root 2 over 2. So basically I'm saying if I use this identity, I should get root 2 over 2. And I know that 45 is in quadrant 1, which is why I've chosen the positive value for sine. All right. Okay, so I basically say, okay, I use this 90 and I substitute into my identity, and then I use that function value. So it's 1 minus, what is the cosine of 90 degrees? Well, it is 0, and then I simplify. So that leaves me with the square root of 1 over 2, which we know then is rationalized root 2 over 2. So we can see that that identity does work. And there are basically the last identities that we are going to learn.